All right, section 3.2, we're going over the graph of a function. And in this first example, we have a graph to our right, and we have about 14 parts altogether. Only 6 questions, but multiple parts. And this first one, we just want to find values. So we're given f of negative 21 and f of 6, and we want to know what they are equal to. Okay, so what this notation means, you want to compare f of x and understand that f of x is equal to y. This means y equal. When they replace this with a number, when they replace x with a specific number, they're telling you x is this number, you tell me what the y value is. All right, so f of negative 21 means that x is negative 21. So you're going to go to the graph, find negative 21. So going to the left, here the order pair says negative 21. The y value associated with that is negative 4. So this one is just negative 4. And then the same thing on the next one, f of 6. They're telling us that the x value is 6. You tell me the y value. So if we look at the graph, we go to the right to positive 6 right here. The ordered pair is negative 4 as well. So both of these numbers give us a y value of negative 4. Okay, so with the next few, we're going to repeat that process. So we're going to look for 18 and 0 in the x direction. So 18 positive, we get a positive value of 4. And then 0 in the x direction, that's right here in the middle. So the order pair where x is 0, we get a negative 2. All right, so now we want to know is f of 6, which means is the y value positive or negative. So they're not talking about this number 6. We got to go to the graph, find 6, and then find the y value. So I'm going to the right. Here's 6. When I go down and look at the y value, it is negative 4. That is the positive or negative that they're asking me about. So the y value when x is 6 is negative. It's a negative 4. This time, f of negative 6. So the same concept. We're going to go to the left, find negative 6 right here, and that is associated with a positive 4. So this time we get a positive value associated with this negative x value. Now we want to know what values of x. So now we're looking for x given that f of x is equal to 0. So remember, f of x is equal to y. So what this means is y is 0, you tell me x. All right, so along this x-axis, these are the values where y is 0. The second coordinate. So when you look at order pairs, remember alphabetical order goes x, y. So I'm looking for the values where the second coordinate is 0. And going left to right, we have a negative 18 right here on the 0. And it says separate multiple answers with a comma. So we have negative 18 is 1. And then we have this other value, this one actually here, where the second coordinate is 0. That looks like a negative 3, 0, kind of merges with that line. So negative 3 for the x value. And then the last one here, you get a positive 12. Okay, so you just find the x values this time given y. Now, this next one wants to know what values of x. So again, we're looking for x values where y is greater than 0. So we want to know where this graph, the parts of this graph above the x-axis, which is greater than 0, the positive part. Now it says type a compound inequality, use a comma to separate answers. So when you do an inequality, we're going to be using the less than, greater than symbols. The way you read a graph, remember, you're going to read left to right, just like you would read a statement. So going from left to right, this graph is at 0 when x is negative 18. So that's going to be my starting point, negative 18. And then it goes above, and it stays above until we get to the x value of negative 3. So we're going to say negative 18 is on the left, so it is less than, okay, all of the other x values that are positive. So we put less than x, and then that goes over here until we stop at negative 3. So what this inequality means is that this graph is positive from negative 18 to 3. So all of this section here, you define it based on the x-axis. And so this is the notation. But there's another part that's positive, this part over here. So that part is positive starting from 12 and going to 18. You look at the x values. So 12 less than x. This time we're going to say less than or equal to, because this point is included in the positive. Now I didn't put the equal to on these guys because they're equal to 0 and we want to know greater than 0. So when we actually get to 18, that number is included in the parts that are greater than 0. So we have from negative 18 to negative 3 gives me this part above 0. And then from 12 to 18, 18 is included in that part greater than 0. All right, what is the domain? So domain is looking at this graph, the furthest to the left, all the way to the right. So the last point we have is negative 21. We're going to type it as an inequality. So we're going to say negative 21. And since it is a closed dot, it's equal to that point. So we're going to say less than or equal to x. And that is going to be less than or equal to the furthest point on the right, which is 18. Okay, so all of those points are included, this whole line segment. The range looks at the y direction from bottom to top. You always go smallest to largest. So the smallest point, the furthest to the bottom we get is negative 4. It's 2 points, but it doesn't matter. We just want to know the lowest point. So our range goes down from negative 4, which also is less than or equal to all of your y values, that's the variable, and that is going to be less than or equal to the highest point. So the highest point is a y value of a 6. So domain, you look left and right, the furthest to the left, furthest to the right. Range, you look top to bottom. Bottom first, up to the top, smallest to largest. Okay, so now we want to know what are the x-intercepts. So remember, x-intercept gives me y value of 0. So remember, y is the second coordinate. So we already listed those. We want to type an integer or fraction, use a comma. So we don't actually have to type the ordered pairs. We just need the x values. So negative 18 and then negative 3, okay, similar to what we did before, and then the positive 12. So those are the three values where y is 0. Those will be my x-intercepts, where they actually cross the x-axis. What are the y-intercepts? So where does this graph cross the y-axis? Right here. So here now x is 0. We get a y value of negative 2. So just one y-intercept, negative 2. How often does the line y equals 1 intersect the graph? Okay, so y equal 1 would be a horizontal line just straight across when y is 1. Runs just like this, horizontal. So if you did that, it would cross 1, 2, 3 times, okay, because this graph sticks up 3 times on the positive side. So at y equals 1, this would cross 3 times. All right, how often does the line x equals 2 cross? Okay, so over here, x equals 2. So this is on the x-axis. An x line would just go straight up and down, a vertical line. So x equals 2 would only cross 1 time, right here. So we don't need to know where, we just need to know how many times, and it would only cross once. All right, for what values of x, so we're looking for x value, does y equal -4? So our y value is -4, so here's -4. What are the values of x? So you got to look left and right. There's 2 of them. There's -21 as an x value, and then +6. So we say -21, 6. And then the last part, for what values of x, so again we're looking for x, do we get a y value for 6? So we go up to the y value, we find 6. There's only one of them. The x value is -9. So the key here is just making sure you understand what each of these are asking. Either they give you x and you have to find y, or they may be giving you the y value and you have to find x, but it's just interchanging those two ideas.